19.3 Task 1 Data Gathering Techniques. Compare samples and populations. A population is a group of individual members. You can collect data about a population by surveying or studying some or all of the members of the population. The study of all members of a population in order to gather data is called a census. A parameter is a number that summarizes a characteristic of the population. The study of only some of a population's members in order to gather data is called a sample. A statistic is a number that summarizes data from a sample and can be used to estimate parameters. A national organization is working to improve education in the United States. The organization is trying to gather data about third-grade students from all across the country. What is the population in this situation? The population would be all third-grade students. All right, a class of third-grade students is a sample of the population. Right? One sample of the population could be all the third-grade students in the United States who are homeschooled. What are some other examples of samples of the population? Select all that apply. All right, so all of the data collected by the organization, that would be a census. Remember, all the data is a census, not a sample. Sorry, lost my train of thought there. All right, so all third grade students who live in a particular city, so that would count as a sample. An analysis of the data collected by the organization. Nope, not an analysis. All third grade students who attend public school. That one would work. The results of the study. No, we're not looking at the results. And all third grade students in South Carolina. So each of those three would be considered a sample. Because you're not looking at the whole group, you're looking at just one particular sample. All right, a parameter might be the percent of all third grade students who read above grade level. What are some other parameters that can describe the population? Select all that apply. So the percent of all third grade students who can read at grade level. That sounds like a good parameter. The percent of third grade students in North Dakota. The percent of all third grade students who are the oldest child in the family. All right, that we could look at that. If there's 2 or 3 kids or 4 kids or however many kids, we could look at the oldest child and see if they're in third grade. The percent of all elementary school who read at grade level. So we're not looking at all elementaries, we're just looking at third graders. So the percent of third graders who take a bus to school, we could look at that. And again, this one's talking about elementary instead of third grade. So I think first, third, and fifth are the best parameters for that. All right, D part says a statistic might be the percent of all third grade students in a classroom who read above grade level. What are some other statistics that can describe samples? Select all that apply. All right, the percent of third grade students in South Carolina who take a bus. All right, that sounds like a good statistic. The percent of elementary school students in South Carolina who can read at grade level. All right, so we're looking at something that can describe a sample. All right, so this would be kind of looking at the whole population. If you're looking at the percent of elementary students in South Carolina who can read at grade level. Again, we're looking at elementary students in the whole state. So that's not going to be one. And the percent of third grade students in South Carolina who can read at grade level. That sounds good. The percent of third grade students in a classroom who are the oldest child in the family. That sounds good. The percent of third grade students in Europe. Okay, so above it said in the country, so that would not be one. The percent of third grade students who can read at grade level. Okay, that would be the whole population, so that would not be what we're looking at here. So the first one, the third one, and the fourth one are the best choices for that. All right, so it says, which type of study is more comprehensive, a census or a sample? What are the advantages to each type of study? A census is more comprehensive because it includes the entire population. So when you do a census, it counts every single person to get data from. So it's going to be more accurate. A sample, the advantage to doing a sample is because it is a smaller group. It is maybe quicker to get that data and easier to collect data to get that information from. So there are useful things for both a census and a sample. All right, that's all for task 1. If you have any questions, let me know. Lesson 19.3, task 2. Explore sampling methods. Conducting a census of an entire population typically requires a lot of time and resources. Sampling the same population can be a more effective alternative. The sample statistics can then be used to make good estimates of the actual parameters of the population. A representative sample provides a statistic that is a good estimate for its corresponding population parameter. A biased sample is one that does not fairly represent the population. A biased sample can produce statistics that can lead to inaccurate conclusions about population parameters. Sampling methods vary among different surveys, and some surveys use multiple methods to limit the potential for bias. Other times, people conducting surveys are focused on a high response rate, speed, and ease in finding a sample size that is large enough. All right, so different sampling methods. The first one is a simple random sample. Each individual in the population has an equal chance of being selected. A self-selected sample, which is exactly what it sounds like. Individuals volunteer to be a part of the sample. A convenience sample. Individuals are selected based on how accessible they are. A systematic sample. Members of a sample are chosen according to a rule, such as every nth individual in the population. A stratified sample. The population is divided into groups, and individuals from each group are selected, typically through a random sample within each group. And a cluster sample. The population is divided into groups, and some of the groups are randomly selected, and either all of the individuals in the selected groups are selected, or just some of the individuals from the selected groups are selected, typically through a random sample within each selected group. All right, so a high school student council wants to know student opinions about a new dress code. All right, so the student council surveys students about the new dress code. What is the population in this situation? Parents, teachers, and student council, school board members, parents of the students who attend the high school, the students who attend the high school, and teachers at the high school. So since they're doing a survey about the students' dress code, the population would be the students who attend the high school. The student council surveys all students who are assigned lunch during the first lunch period. What is the sampling method? Is it likely to lead to a bias? All right, so a self-selected sample, a simple random sample, a cluster sample, a convenience sample. So since they're using all of the ones in first period, that would be considered a cluster sample, which represents the population as a whole and is not likely to lead to a bias. As long as everybody assigned to first lunch is random and it's not like all one grade or something like that, then that would still be a random sample and it would not lead to a bias. All right, the student council surveys 2 randomly selected students from each English class. What is the sampling method? Is it likely to lead to a bias? All right, this would be a stratified sample. Let's see. Let's review what these were. All right, divided into groups and individuals from each group. Okay, so a stratified sample, if they're choosing 2 people from each English, everybody in the school has to take English, and they choose 2 people randomly from each English class, that would be called a stratified sample. All right, the student council surveys students by leaving index cards near the entrance of the school for students to write down their comments about the dress code. What is the sampling method? Is it likely to lead to a bias? All right, so a cluster again, a self-selected. All right, so we can see that it would be self-selected because you decide whether you want to do the survey or not if you write on the index card. You're choosing to, and which would not likely lead to a bias, and this one says which is likely to lead to a bias. So I'm going to go with this one because if you take time to fill out the survey, you probably have a strong opinion one way or the other about the dress code. So if it was a random sample, you're going to get different opinions about the dress code, but if people are choosing to do a comment about the dress code, they probably, again, have, like a extreme one way or the other. Like they really want a strict dress code or they want a very lenient dress code. All right, E says the student council surveys students by stopping every 10th student who enters the school and asks for opinions on the dress code. What is the sampling method? Is it likely to lead to a bias? So we've got a cluster, systematic, self-selected, stratified. This one I believe is systematic because every 10th one, if you remember, systematic members of a sample are chosen according to a rule such as every nth individual in the population. So if we're surveying every 10th person, that would be a systematic sample. Describe a method. Describe a simple random sample that the school council could use to survey students about the dress code. Do you think this method is likely to lead to a bias? So to describe a simple random sample, they could just randomly choose so many names, like 50 names or 100 names from the entire population of the school and do a survey that way. Would it be biased? It should not be biased. It is if it's truly random. If for some reason a large portion of that group all comes from one grade or maybe one sport or all are in the band or something like that, then it could have a bias. But if it's truly random, just you choose 100 students out of the whole school and just choose from the entire name population, then it should be without bias. All right, that's all for task 2. If you have any questions, let me know.